For yesterday, we left the question at number, when I said we are going to continue, where did we end yesterday? Before we found the roots, isn't it?
We left where we were supposed to, where we had two equations. Yes.
Where we were having two equations here.
Mm-hmm.
So these are the two equations which they are referring to, the two equations for the motion of A, where they're saying write the two equations for the motion of A and the motion of B. So we solved the two equations of motion of A and motion of B. So which means we have answered this part.
Which one?
Write down the equations of motion of A and B. So write down the equations of motion of A and B. That is what we derived here. So the equations of motion of A and B. These are the equations of motion of A and B. So this is the equation of motion of A, and this is the equation of motion of what?
Of B.
Of B. So this is question number 4A. These are the solutions for question number 4A to arrive at that point. So you clearly indicate that these are the equations of motion of A. It's only having the first particle, which means XA, mass times acceleration A. And then the equation of motion of B, it is the second one.
Yeah.
So solution for A, it's out. Now, from there, we want to find the roots, which is now we are dealing with part B. We want to find these roots, which are for part B, where after putting W naught is equals to square root of K over naught, we want to show this. So this is what we are doing for part B. Once we can show this and these roots, then we are done with part B. Then we can move to the next part, which will be C. So this is part B. So part B is the one that we want to solve for part B. So let's see from where we left how we are going to maneuver. So for A is done. So part B, we are having those two equations of motion. Then we said we assume that XA is a what? Is a solution. And XB is also a what? A solution. So XA is satisfying the first equation for A. It's the solution for equation for the first one. And the XB is this one which is satisfying that equation. What do we mean by that? When I was showing you yesterday that how do you differentiate XA, the derivative, where I was saying it's equals to, when you are differentiating A, e to the power I omega t. Remember, this is a what? A constant, isn't it?
Which one? Sorry.
I omega. I omega is a constant, isn't it?
Mm-hmm.
So this part of differentiating, are we still going to explain it, or is it clear? How we got these values?
That yesterday.
Yes. It's clear, isn't it?
Mm.
Yes, how we got these values which are in front here. So we are not going to differentiate again today, because I already differentiated.
You use the exponential rule there.
In the exponential rule, yes. When we are yes, when we are getting these values. So this is mass times acceleration and then mass times acceleration. They've replaced it with m omega, with omega squared b. So it's coming from there. So after you multiply, you replace, we are also going to divide. Can you see on the equation, there is no e to the
Yes,
power I omega t. It's not there. So you divided the equation by this constant. In other words, the equation was supposed to be, after you write a, you are supposed to write e to the power I omega t. But they divided, where there's a, you were supposed to put multiplied by e to the power I omega t. Everywhere where there's b, you put e to the power I omega t after differentiating. That's why they said dividing both sides by e, which means you are going to divide this term by e to the power I omega t, e to the power I omega t, and then this you divide by e to the power I omega t, 0 divided by e to the power I omega t. Here you still get 0, this they cancel, this they cancel. That's why our equation is no longer having e to the power I omega t. You get it? Why it disappeared? It's because you already divided by what? By e to the power I omega t.
sorry,
That's
is
what
that the e to the power I omega t? Is it given
yes.
on the question?
No, this one is not given. We assume, it's an assumption of the solution. We assume that the solution that satisfies that equation, it's of the form where that is of the form a is a constant and an exponential. Remember, what satisfies differential equation is an exponential form. E to the power kx, remember from differential equations, it's exponential. Any form that satisfies the differential equations, a constant to the power rx, which means I omega t. So this is your trial solution. You assume it was not given, it's an assumption. When you are solving differential equations, yes, you have to make those assumptions depending on your solution, whether it's a homogeneous equation like the one which you are given there.
Okay.
And xb is equals to b to the power I omega t. So they must just correspond. But when you're substituting the derivatives into the second equation of motion for b. So now we want to solve for a constant. Substitute into the equations of motion, divide by e to the power I omega t. That's what I'm saying, that in this equation, we are no longer having e to the power I omega t attached to a, this which is attached to a and b. Why? Because they said you are going to divide by it on each and every term. So once you divide, it will cancel here, it will cancel there, it will cancel there, and then cancel. Then you'll be left with only the constants which are there without e to the power I omega t.
That's why it didn't include it.
That's why it didn't include, because we said we are going to divide by it. So when you divide by it on each and every term, it goes, it vanishes. That's why it's no longer appearing there on the equation. So that statement is very important. It says substitute into the equations of the motion and divide by e to the power I omega t. Okay. Then now, once we are done, we want to solve that system using the matrix. When you are solving for that system, you want to use the matrix form. And what are we trying to solve? We want to solve for omega 1. What are the values for omega equals to? That is our mission. Our mission is to solve for the value of what? Of omega. So our matrix, this we can put it in the form of a matrix. For example, we know how do we interpret a matrix. We say this first term, if you are to multiply this term, K naught plus Kc minus omega squared multiplied by what? By A. So everything there being multiplied by A plus this term multiplied by that is equals to 0. That is how we interpret it. So we say this times that plus this times that is giving you 0, which is this first equation when you are putting it in a matrix.
Sorry, can I'm lost there. Okay, that part I understand, the equation I understand. How can you please explain the matrix part?
Right. So we are factoring out things that are having A. Let's
Okay.
factor A on the first equation, our first equation. And remember, our equations of motion, that the one that we derived, we rewrite them in such a way that we are having A is outside, like here, substituting the values into the equations. After we differentiated, now we are here. We have removed the value of XA. Now we are using M omega. Right, that is where we are coming in. So now we are using M omega squared A and M omega squared B. So everything now is fine. It's each and every term is either being multiplied by A or B. So the first term that is being multiplied by A is this one. If you factor out A on this term, you factor out A, what are you left with?
We're gonna have negative
The A,
MW squared.
the A that factored out is this one in terms of matrix. So we are saying if you factor out A, what are you left with? It will be minus what?
Minus MW squared, and then plus KO plus KC, negative case. No, the B, are we also?
No, only A for now. Plus K
C.
naught
K
plus
naught
what?
KC.
Plus K what?
C.
K. And then here they just rearranged. Or if you want, you can leave it like that. But I want to explain what happened here. They just rearranged. Just KO plus KC without changing the value minus M1 omega squared.
Okay, they just rearranged.
Just rearranged. So after they rearranged, we know we are having two constants which are having on both equations, which are A and B. So how do you interpret this equation in a matrix? The first equation, it means this term which is being multiplied by A, it comes first because it's this term times this A. Because we factored out the A, isn't it? The A is there. Yeah, the A must be there, which means we are multiplying it by what? By A.
Okay.
So this is the A in the matrix.
Yes.
Then the KC, this one, which is having a negative. It's being multiplied by B, which is the bottom, which means our matrix is A and B. Since we want to solve for omega, so we are putting the equation in a matrix. So two matrices, the first one, they must give you an answer which is equals to 0. So this is the other matrix which is on the right hand side. So it's equals to 0, 0, both equations. Then you
So
do
what
the
is happening there on the equation under right in matrix? You wrote that K naught plus KC minus omega squared. Ne? At the bottom you wrote negative
we are
KC.
on the bottom first. We are still on the top. We have not come here yet. This one I have
Where
not
are
touched.
we?
We are just
Okay.
first one, where we are saying we factored out. So which means this whole term multiplied by A, this whole term is being multiplied by what? By A.
By A.
That's what
Okay.
we factored out. And then KC is being multiplied by B. So this is the KC, it's being multiplied by what?
By B.
And then for the first line, it's equals to what? 0. We have not touched the 0 at the bottom. Yep. That's what we just need for now. Then now we are going to the second equation, where we are saying M omega is being multiplied by B. You factor out the B, like what we did. So it will be the same equation. It will be minus M, factor out B, omega squared, plus K naught, plus KC. Everything is being multiplied by what? By B.
By B.
When you rearrange that equation, the first one, it will be multiplying by A. When you rearrange like what we did there, you're starting by K naught, which means it's K naught plus KC minus M
Omega squared.
it's multiplied by B. So this is multiplied by B. So the term that is multiplied by B, it comes at the second position. The first position, you put the term that is being multiplied by what? By A. That's how you rearrange a matrix. On the first position, you put the expression that is being multiplied by A, because it's the first term multiplied by the first one. This term multiplied by A, then the second term multiplied by the one which is at the bottom of the matrix. That's why we didn't start by M omega B here. We did not start with this expression here, because it's not being multiplied by what? By A. It's being multiplied by B. So what you put here on the first column are the things that are being multiplied by A first. And what you put on the second column are the things that are being multiplied by what?
By B.
That's how you arrange a matrix. Any question on only arranging the matrix?
No,
Why is it that we not start with this one? We put it here. The reason it's being multiplied by what? By B. So it must come on the second what? Column. KC is being multiplied by what? By B. It must come on the second column. Then you rearrange minus KCA. That's why the minus KC is starting, because it's being multiplied by what? By A.
I was still doing physics or doing calculus, yo.
The mixture, yeah. It's being
Yeah.
multiplied. Then from there, we solve. Once you know, we want to solve. Remember our idea, we want to know what is omega. Once we solve for omega, we are done. That is why we are doing this. So when you are solving for what is it, linear algebra, you did linear algebra, isn't it?
I did, yes.
Yeah. So in linear algebra, once you have a system which is like this, solve it using the method of undetermined coefficient, or you can use the non-trivial solutions, where the determinant, it means this times this minus this times this, it will give you what? 0. So this is this times minus that times that, it give you 0. Then we can solve for omega. That is why I put it in the matrix form. The idea of putting in the matrix form, we know that if it's having a solution of 0, it's going to be easy for us to solve for omega. Why? Because we know that if we cross multiply like this times that, minus this times that, my answer is going to be 0. The determinant, this is how you calculate the determinant of a 2 by 2 matrix. Just given a 2 by 2 matrix, whereby it's A, B, C, D. Determinant, we know that it's AD minus CB, which means this minus that. That's how we calculate the determinant of a 2 by 2 matrix. And in that case, if it was equals to 0, 0, if that was like this, 0, 0, even yourself, you know that this is equals to what? 0. Then you solve. Yes, that's what. So that's the mathematics that we are using here. And the idea, why are we doing that? We want to solve for omega, which is that W. Any question? There is no question. So we have put it there. Now we want to solve for that omega. How are we going to do it? We are now doing the determinant form. So these two we are seeing after you rewrite. Why did you rewrite the expressions? You rewrite so that you can see that these two things are the same. This term and this term, they are the same, isn't it? They are the same. So if I cross multiply, if I do like this times this, so which means I'm going to get a square of those two expressions, two things which are the same. This is the square which they are talking about here, which is here. This square. Can you see these two?
Yeah.
That is showing that there are two of those expressions. That two. It is representing two of these K or naught plus KC minus M omega squared, which means two brackets of this. So the first bracket, 1, the second bracket, now it's a square. That's why the 2 is there outside. Right. So this, I've shown you why it's a 2, isn't it? Outside. Cross multiply. Okay. Cross multiply. Now, let's see the other side where we said we are going to multiply like this. So now we are cross multiplying. So it's minus bracket minus KC multiplied by minus KC. That's what we are doing. So it's minus KC squared minus KC times minus KC. It's minus KC squared. So minus and minus give you a positive inside the bracket. So positive and negative, which is outside for subtracting determinants. That's why the negative, positive and negative give you what? Negative.
So what is the purpose of writing the matrix in a matrix form?
The matrix form is the fastest way there to solve for omega.
Okay.
Solve for omega. So the reason why we put it in the matrix form, it's a fastest way to solve for omega. Remember, we are given two equations. These two equations. Yes. So instead of going the route of simultaneous equations, you eliminate A and B, substituting back. Matrix is the fastest here. There is an option of using simultaneous. You form equation 1, then you form equation what? Equation 2. After that, you make A subject of the formula. Then you substitute into equation 2. Then, so you find out it's going to give you a long step. So the fastest method was just to use what?
Matrix. Okay.
You find out using simultaneous, by now we should be working. We wouldn't be done. So matrix was the fastest. Because once you know they give you 0, then you just find the determinant. So it means this times this minus this times that. Then from there you can solve for your omega. Like what we are doing now, we have an equation which is like this. This is our equation. It's come out. So squared minus kc squared is equals to what? Is equals to 0. So the question now, solve for what? For omega. That's what we want to do now. So let's delete these ones so that we can solve for omega while we are seeing that it takes at least faster than solving using the matrix way. I mean the simultaneous route. The simultaneous equations, it's also another alternative, but it takes a bit of time. Any question to where we are so far? Where you need clarity, where you don't know how we arrived. How did we put the matrix form? This is the equation which we put in the matrix form. The first things that are having A, we put them on the left. The things that are having B, we put them on the right side of the matrix, of the first augmented matrix. Right. Then from here, we have our equation, which is this one. From here, now you use your mathematics, solve for omega. It shouldn't be difficult here. Now you're just using the maths. Right. We want to make omega subject of the what?
Of the formula.
Okay, so let's do it so that we see. Once you're here, after you get your matrix, now you make omega subject of the formula. How do you make omega subject of the formula? Push this to the right. Isn't it the equation? Push it to the right. So we start with K naught plus Kc minus M omega squared. And everything is in the other big bracket, which is what? Squared is equals to minus Kc goes to the right. It becomes Kc what?
Kc squared.
Kc squared. That is the first step. Now, when I want to remove the square root, which square root do I want to remove? This one. I want to remove that square. So that square, which means I must put a square root on the right-hand side. So that's what we want to do. So which means I will introduce a square root on the left. So it means if I come, I introduce a square root here. I can also introduce a square root here. That's what it means. So that you are left with what you do on the left, you must do it on the one.
The right.
So we are left with K naught plus Kc minus M omega squared is equal to, what is the square root? The square root of K squared C. Of
We
Kc
left with Kc.
To be Kc, which is, remember it's a square root, can be plus or minus what? K?
Kc.
Kc, that's it.
We have
Square
to
root.
indicate that they
Yeah.
plus or minus.
Plus or minus Kc, the square root. There are two options, either it will be a minus Kc squared, or you squared a positive number, plus or minus.
Or whenever there's a square root, the answer should always be plus or minus.
Plus or minus, yeah, plus or minus. All right. Then from there, remember our idea is to solve for what? Is to
For
solve
omega.
omega. So that's where we are. And then we say, okay, we are there. You choose which one you want to push on the left or on the right. What do you want us to do? Should we push
Ko
omega?
plus Kc, take it to the other side, and we are left with negative m omega squared
Yeah, we are going to end up dividing
by m.
So what do you do?
We take K naught plus Kc to the other side, and then we are left with negative m omega squared on the other side, and then we divide by negative m on both sides, and we are left with omega squared, and then we introduce the square root both sides, and then we are left with omega,
which is also the same by just what you are saying, by just saying K naught. The
yes.
first KC. Then take plus or minus the left. That is the one which I used to write like this, minus plus. You still remember? KC.
Or you take the
Isn't
negative
it?
m.
You were starting by positive, negative. When you take it to the left-hand side, it will be minus plus. But the meaning is just the same. It's still plus or minus. It's just they are trying to be specific to tell you that I've indicated that I pushed plus or minus KC to the left. But mathematically, starting with a negative plus or plus or minus, you mean the same thing. It's just the same like 2 times 1, and someone says 1 times 2. They are just saying the same thing. So here you can still put plus or minus KC, and then the M omega, push it to the, you just save time of dividing. Then now you want to be left with omega only, which means I'm going to divide by what? By M. So it will be K naught plus KC plus or minus KC, everything divided by M is equals to omega squared. Is that clear? I want omega, which means I'm going to get the square root of everything that is there, isn't it?
Yes.
So come here now. Here, this step, which we are having here. Are we agreeing now?
Yeah.
So for omega squared, this is the omega squared, which we are solving for, is the same as K naught plus KC plus or minus KC over M. Is that clear there?
Yeah.
Then from there, you solve for omega, the quadratic equation now. So how are we going to solve for that omega? We come here to solve for that omega by saying omega is equals to square root of everything that is under the bracket. So it's square root of K what?
K naught plus KC plus or minus.
Yes, square root of
KC
K naught
over M.
Yes, plus KC plus or minus what? K what? KC, everything over what? Over M. We've introduced the square root. That is your KC. Yeah. So, which means from here, that's where you are going to get the 2 roots. So, in the 2 roots, which means they are going to come from here, where there is this plus or minus. Can you see this plus or minus?
Where?
This one, plus or minus. That's where the...
Yeah, I wanted to ask, what are you going to do about that one? Because I was just going to write positive.
That's where the 2 roots are going to come. The 2 roots are going to come. So let's continue. So which means if I want the first root, my first root, I'm going to say omega 1 is equals to square root, isn't it? So you choose which one you want to start with. If you want to start with the positive one, or if you want to start with the where you put the negative. Okay. But we have been told in our question, we have been told that W1, let me show you. In our question, we have been told that W1 is equals to what? The first root, it must be equals to what? W1. Not. So for something to be W0, it means this W0 must be equals to square root of what?
Okay.
K naught over what? Over M. That is your W0. That is the formula for W0. So which means if we are looking for the first root, they've already indicated to you that the first root must be such that it's equals to W1 naught. So which means here you are no longer going to be choose anyhow. You are going to choose so that you suit that condition which was given there. So which means my first root, I'm going to put a what? Kc minus. So that it will be like this. It will be K naught plus Kc minus Kc over M. That is my first root. What is Kc minus Kc?
Oh, you want to get to satisfy the
That
given.
condition of
Oh,
so that Kc minus Kc, they cancel. Then I'm left with what?
K naught over M.
K naught over what? Over M. So that I said that condition which I was given to say satisfy this condition, which says W naught, W1 is equals to square root of K naught. K naught over M, which is the same as W1 is equals to W1 naught. Why did we not choose a plus? Because plus is not going to give us W1, which is equals to W1. No.
Yeah.
So I do make sure that I satisfy the conditions which were given here on the question. Here on the question, I must satisfy this condition. W1 must be equals to W1 naught. And where did I get this W naught is equals to K naught over M? It was given.
It was given.
Naught, yeah. Putting the W naught equals to K naught over M. So we are using every information that we are given. We are using. So once I'm like here, the other root, what is the other root going to be equals to? So the other root is going to be equals to what? So you come here, where there was where I put a negative, now I'm putting a what?
A positive.
So which
So
means
that's
my
gonna be W2.
second root, yes, that's going to be W1. W2.
Okay.
So W2 is going to be the square root of K naught plus Kc plus Kc. So in your working, you must indicate it. Say it's K naught plus K what? C plus what? K C. Everything over what? Over M. Then indicate that this W2 is equals to the square root of K naught over. All right, let's add K naught plus 2 Kc over M. And then show it as individual. They are sharing the same common fraction, which means W2 is the same as the square root of K naught over M plus 2KC over what?
Over M.
But what is this over M? This is what we are talking about. To say W2 is the same, is equals to the square root K naught over M. We already indicated that this is W1. W naught
Yes.
plus 2KC over M plus 2C over what? Over M.
Over M.
And my question is saying I must prove what here on the question when we are talking about the second rule. Show that W2 is equals to W squared plus KC over M, 2KC over M, which is what we have proved here. This is what we have proved. So W1 is equals to this, which is square root of K naught over M, which is that. And then you show here where you get K naught over M, and then this is K naught over M. This one, it's omega squared. There's a 2 here, so it's that one, there's a 2. Omega naught squared, because that is only this one, which is K naught over M. K naught over M, the one that is inside, it's omega naught squared plus 2KC. So we have proved B.
You said that omega naught ne,
Yes,
is equals to K over M, K naught over M, right? That was.
yes,
So
K naught.
now, what is confusing me is the square, the way you
Yes.
squared W naught. I don't see how you obtain
Where we
that.
stand. It's here. It's this. We are given that omega naught. This was the one which was given. Omega naught is equals to square root of K what? Naught over what?
Over
M.
M.
So where I have K naught have over M, this only this that is inside. We want K naught over M, which means I must square both sides. If I square this side, I must square also this side. I square. So which means I'm going
So
to have W naught squared
equals to
equals to K naught
M.
over what? Over M. So where there is K naught over M, I replace it with what? W naught squared.
Oh, squared, W naught squared. Oh, yeah. Now I get it.
So we have
So I
proved,
thought it was W naught and then is equals, but now that you have squared it, I understand.
yeah, which is this one, which is this step that we have proved. For showing that W1, the first root, is equals to this one, we have shown that this second root is equals to that, we have shown. The first two motions, A and B, we have shown. Any problem there?
No.
And so we want to show the other part of B. This is still part B. And that the angular frequency of A and B, the angular frequency of A and what? And B. The angular frequency of A and B is claimed. So here you want the angular frequency of A and B is what? Claimed, which means XB is equals to 0 always. That is
Because
the one
the
when I'm telling you
movement.
that it's not moving. When it's moving, that one, that force B is claimed. It's not. So it's equals to what? To 0 always is given by that. So the angular frequency of A when B is claimed, this one. So we want to show that the angular frequency of A when B is claimed is equals to that. That's the last one. All the other ones we have shown them. What we are left out with this one, the angular frequency of A when B is what? Claimed.
It's claimed.
So
Yeah.
you must have the equation of that angular frequency when B is what? Is claimed. So the other ones for proving, I think I have done justice to prove the W1 and W2, isn't it? I don't
Yes.
think there's a problem for the roots. After you do your matrix, find the determinant. From determinant, now you solve for omega. That's how we are coming with two roots. Instead of you going that route of simultaneous, this one was fair to arrive at the answer very fast. So these are long questions. So you see then that they are long questions.
Yeah, it's very long.
They need your maths, physics and maths.
Combined.
And yeah, you
Oh.
can't you run away from physics and then you learn maths, you run away from maths and then you go to physics. It won't work. But everything is there. Linear algebra is there. All right. So we want the angular frequency of what? Of A when B is claimed. That is what we are saying. So here we have solved our values here. This step, we are done with this one. The two angular frequency which we are having for 1 and 2, these are the ones. We solved them already, where we got that omega squared plus 2kc over m. Now we want to show something else that is different. We want to show this one, that the angular frequency of A is given by kc over m. How the 2 is disappearing there when you are dealing with the angular frequency of A, WA. That's what we want to prove. From what we have got so far, we found everything up to there. So now we are doing right. Set xb, which means equals to 0, which means it's claimed, isn't it?
Yes.
Yes. So which means the equation of motion of A, when that spring, which I was telling you, it was claimed here to A, it was like that. Then this is your A. And then this side it was KC. Still remember? KC, K naught. And this was our A. When I was saying this is going this direction, this is going in that direction, but B was the one which was going in which direction? For that one, KCB. Okay. Then we are here, we are saying mass times acceleration. The first one that we are having from the beginning is the same, nothing has changed. Minus K naught, which is the spring constant, and the X A, the displacement due to the mass A. This is the displacement of the mass A. And then KC, still the same direction, negative, minus KC multiplied by the displacement of the mass what? A. Check the difference. Where is the B now? This B, which we're having it from the beginning for the mass A. This one. Can you see K naught XA, K naught KC XA plus KC XB? That we finish. When you sleep now, won't finish.
No, I'm not sleeping.
So here, remember there was a plus K C multiplied by X what? B from the
So
original.
we are starting from that
That
formula.
yes, that formula which we have. So
The one
we
for acceleration.
yes, set xb to what? To 0. So where
Because
there
it's
is xb,
uh,
this becomes what? Because it's claimed, isn't it?
yes.
That's why it's no longer appearing on the what? On the equation. Can you see?
Uh-huh.
Not there on the equation. Therefore, if it's not there on the equation, my final acceleration looks like this. How? You move everything to the left, like what we did. K naught x to the left, everything to the left, then it becomes positive, positive, positive. Right. Once we are there, it's now positive, positive. Okay. The angular frequency of A, the angular
I don't
frequency,
think sorry, I don't think I'm following. You took the formula for acceleration. I remember we did it.
it was there,
So
yes.
the one that you added, the KC XB, well, can you please explain this one?
This one
The one
is
that you,
plus. It was always like this. Remember, it was always because the B was here, isn't it? This ball B, which was claimed to the other side. That's why I say it is
oh
yes.
yes.
So in this case now, they say it's claimed, which means
Mm.
it is 0. The displacement of this, it's not going to move stationary. It's claimed. So which means where there is xb, you are introducing what? 0. So if it's 0, 0 times kc gives you what?
Oh, okay.
Because that's why it
It's
falls out from the equation. And how did this 0 come from? It comes from taking everything which is on the right-hand side. We are putting it on the left-hand side. So it's m multiplied by xa. Then we take everything that is on the left comes to the right.
yeah.
That's why it's plus k naught xa plus kc xa. If you expand everything to look like this, it will be the same up to here. Here they just factorize the answer, but they just moved everything to the left-hand side, and on the right-hand side, there's nothing. That's why it's equals to 0. Any question
Yeah.
there? Then now we come to the angular frequency, which we are looking for, WA when B is claimed. So WA when B is claimed, the angular frequency, how did they obtain this angular frequency? That is my question. How did they obtain that angular frequency? Because it's coming from the equation of mass times acceleration. Any standard equation for mass times acceleration, when you are given mass times acceleration for any Newton's second law motion, whenever it's given like mass times acceleration plus k naught, and the displacement could be x is equals to 0. Always your omega is equals to the square root of the coefficient of what? Square root
Omega
of the coefficient of x, which is k naught, over
over
the what?
the
The mass.
mass.
The mass.
Yeah.
So here they've taken out the coefficient xa. So they want to see what is the coefficient of xa. That is your k naught. In place of k naught, now we are putting two things, isn't it? In place of k naught, instead of just putting k naught once, we are putting the whole coefficient of what? Of xa, which is k naught plus kc over m. Then you just separate them. You indicate that k naught, like this, WA is equals to the square root of k naught over m plus kc over m, like that. That's where the omega squared is coming from. So square root it will be omega naught squared plus Kc over what? Over m. So the fundamental was coming from here to say, do you know the equation when we set xb equals to 0, it vanishes. If you are given a standard simple harmonic oscillation equation or differential equation, do you know how to derive the omega? Omega is just the square root of the coefficient of that displacement of x. And first you must set everything equals to 0 before you talk of the coefficient. So everything must be equal to 0. And the coefficient of x, it will be k naught plus kc. That will be what you are going to replace. Then we have shown what they wanted us. Yeah.
So okay.
For number
The,
WA is equals
yes.
to
The formula for W naught squared,
M.
W naught, it's the square root of K naught over M, right?
Yes,
So
this
I see
formula.
that we also added the KC there because it's a coefficient as well.
The KC, it's coming from our diagram. Remember the diagram which we were discussing yesterday? The spring.
The two objects, yes.
This spring mission. So it was like this. So when we are talking of the Kc multiplied by the displacement in this direction, and also K naught multiplied by the displacement of x of displacement XA, and Kc multiplied by XA again moving in the same direction, which is the negative, but plus, which means K naught multiplied by the displacement of X what? XB. Because this ball is moving to the what? It's also moving to the right, which means ball B. But we were given a condition to say what is the angular frequency of only this ball. If we say this ball is no longer moving, it's claimed, it's stationary where it is. So which means all these equations, we disregard them. We only focus on K naught and what? Kc. That's why on our equation, we don't have Kcb. We are only focusing on K naught and Kc only on our equation here. We don't have Kcxb because it has been claimed. That's why it is here.
So what is I want to know the difference because the equation, the omega is equals to the square root of K dot over M. Now the WA is it's
Angular frequency only for the ball A. Only for ball A. Only for ball A. We can also have the angular frequency for ball B, but it was not asked in this question. You get it?
so if the object A was the one that was claimed, will we still
And
go to write the formula the same way?
yes. If they want the angular frequency of what?
Of B of object B or
Oh,
yeah
yes.
WB.
When A is claimed, you are just doing the reverse. When A is claimed, which means instead of using this formula, we are going to come and say mass times acceleration of B. Mass
Oh,
times
so
acceleration
sorry to interrupt. The WA is that's you are showing that you are calculating the angular frequency of
of A,
object A.
all yeah,
Oh,
of that mass A. That's what it means. Of A, we are
oh, I thought it
of A.
stands for something. That's where
No,
I was being confused.
so we are calculating the angular frequency of this mass object A.
So the KC you added it because it's also moving towards
Left,
the A
yes,
object.
when it's vibrating
Oh,
towards the left. But this one
okay.
was attached to the right, That's why it's also moving in the opposite direction. That's why we're adding plus.
Uh,
So we are done with A and B. We are left with what? C and D.
it's
C and
still continuing.
D. We are left with C
Are we
and
not
D.
done with question 4?
No, we are left with 4A and B. We are done. What's left is C and D. We are left with C and D. This one. Let me show you. C and D. So for now, we are done with A and B. Now we are left with C and D.
Yeah.
So you C and D so that we know what we are. I sent it on the group, but it's only that you need explanation so that you understand, because these things you can't understand while you are just here. So for C, we'll be calculating the numerical data above. Calculate the expected frequency. This mu 2, which means the expected frequency mu2 of higher normal mode observed at 2,2 per second. The same data, we are going to calculate the ratio of Kc of the spring constant. So it's C and D that we are finishing.
Okay.
Okay. For A, B, it's sorted. We are left with C and D. And whenever you see per second, it's hertz. Remember, I told you that the frequency is equal to over what?
1
T.
over T.
So whenever you see frequency, hertz, always correspond with what? Per second. They are always the same. So whenever you see per second, it's hertz. They are
Okay.
inside. At least you are following. It's good. At least I can see. Once you replay the video, you
Yeah,
won't.
I'll understand more.
Yeah, you just pass it here. So C and D, those are the last one. Then you can go to the last one, which is number 5.
Okay. No problem. We'll do
I'll
that
share.
tomorrow, ne?
Yeah, tomorrow. I'll share the recording on the group.
Okay. No problem. Good night.
Yeah, same.
Bye. Sharp.